Welcome to Pomodoro Joe for Sunday, April 16th, 2023. Today we're looking at LeetCode problem 1639, number of ways to form a target string given a dictionary. This is a hard problem. So you're given a list of strings of the same length, words, and a string, target. Your task is to form target using the given words under the following rules. All right, so the target should be formed from left to right. To form the ith character, 0 index, of the target, you can choose the kth character of the jth string in the words if the target at I is equal to words j, k. What the f? I am going to skip over actually reading this because it is crazy. All right, so in this problem, we are given a list of words, as you can see here, and a target word. Now our goal is to form this target word. So our goal is to form this target word, but we have to follow some rules. We can choose any character from any of our input words, but once we choose that character, we cannot choose another character that comes before that character in any of the other words. So essentially, we choose an index. We grab the character out of that index. Now, any index that comes before this index or is equal to this index is no longer valid. We can only choose characters that are to the right of that index. All right, so in this example, we have target ABA. So one option is we choose the A from the first word here, and then we can choose the B from the second word. And then we choose another A from the third word. So this is super complicated. And before I put time on the timer, let's take a step back and think about how we're going to solve this one. So the basic idea is we can choose any character at any index. But once we choose that character, we can no longer choose a character that comes before that index, or even at that index in another word. So, all right, we want to find all the characters that match our very first character of our target word, and then we can multiply that by how many times we find the second character that comes later in our sets of words. And then finally, we have to find the last character, and it has to come after all the indices of the first two characters. Oh man, okay. So we'll put 25 minutes on the Pomodoro timer and we will get started. I don't have a ton of time today and this one is complicated, so I probably won't be explaining this very well. I'm just gonna dive in, start writing code. I'll try to explain it, but apologies in advance if this is not very interesting. Okay, so the first thing I think I wanna do, I want to be able to find characters by their place in the target. Actually, I want to find characters by their place in the input words. So let's create a grid where the column is the place in our input and the row values represent all of the letters. So this is a mapping. So basically we'll say for the first column or the first character of all of our words, how many A's, B's, C's, D's, etc. are there in that column? Then we can say for the second character, how many A's, B's, C's, D's, etc. are in the second column. So then when we're looking for our target, we can say, all right, what's the first character in the target? Let's take a look at our first character in all of our words. How many of those match that first character in the target? Then we can record, let's say there are 3 A's that match. In this case, there's like only 1 A that matches, but we can say, let's say there are 3 A's that match. Once we find that, then we can look at all the characters to the right of the character. So we find column 1, all the A's. Then we look at column 2. Now we're looking for a column or target character B. This is going to be complicated. Let me just write some code and I'll do some prints so you can see what I'm doing. All right. So we'll start with the result and we will return the result at the end as usual. Now in this case, I want to do some setup. So let me get some basic parameters here. Like, let me get the length of the words. Okay, so I've got the length of my words and the length of my target. Now let's go through and create our grid of variables here, our grid of characters. Let's see, so each row will have zeros to start with, and that's times 26, because that will represent a character. So that's how many letters are in the alphabet. And we'll say for every all right, so our grid is going to be a bunch of zeros, where every row corresponds to A through Z, and we have the same number of rows as characters in our word. So we can look at character at index 0, and we can see how many A's, B's, C's, D's, etc. there are. So now we actually have to fill this in. All right, so we have to go through every column. All right, I think I'm going to need a helper function to get my character translated into an index. So since I might do this multiple times, let's use caching. All right. All right, so let's see. For every I in our word length, we'll get the index for that word or that character. Let's see, I need to go through every word. Right. All right, so we're just going to print this out for now just to see what it looks like. Okay, so this is our grid. So this is going to be in our first row or our first column, basically in the first position, index 0 of each word. There's 1A, 1B, and 1C, and that looks like it's right, 1A, 1B, 1C. In the second column, or second letter, again, there's 1A, 1B, 1C. Is that right? C, B, A, that's right. In our third letter, we have 1B and 2 C's. Let's see, two C's and 1B. And finally, we have 2 A's and 1 B, A, B, A. All right, so this looks good. So we have this mapping that tells us how many characters of a particular type are in each column or each position of our word. So that's going to help us out later, but we don't need to print it. So let's get rid of that. All right, so now I need to go through, find for every word, or I'm looking for target characters now. So let's do this. So let's define a result for a different set of inputs. Okay, so now we're going to do our numWays recurse, and in this we're going to have a starting index and a target index. So in this case we're saying starting from some index in our dictionary word. So basically we can start at 0, but as soon as we choose a letter, then we can't go we can't choose any letters that came before this letter. So essentially we'll say we're going to start at index 0. Find all the letters that match our target index letter. Once we find those letters, then we have to move our starting index to the next letter over. So we go to index at 1. Now we can also advance our target index so that we can look for the next character in our target. So this is just saying, starting at some start index in our dictionary words, how many of our target character can we find? All right, so let's see, this will be recursive. So we'll have some result equal to 0. We'll return the result at the end. And let's see, let's start with some base cases. So base case, if our start index is out of range or our target index is out of range. So that's pretty easy. So if our start index is greater than or equal to our word length, that means it's out of range and we can return 0. There's no ways to form this word, the target. All right, now if the target index is greater than or equal to the target length, same thing, we can return 0. Otherwise, we have a legitimate start index, we have a legitimate target index. So let's find our target character. So this is the character that we're looking for in our target word. That's just going to be the target at this index. Okay, now let's find, do we need to find the target index? Yes, so let's find the index for this target character. That's just going to be our helper function up here, index for char. Of our target character. Okay, so now we know what the target index is, and we'll use that index to basically index into our grid to say, oh, how many of this character do we have? All right, and now we can say, for every word in our word list, let's see, is this right? What do we want to do next? We want to go from the start index. So we're looking for our character starting from our start index in our grid. So that's what we want to do. Okay, so for our current index in the range from our start index to, let's see, go to the end of the word, so the word length. So we're going to go through every character we can in our grid looking for this target character. And then we'll recurse. So if we find this target character, then we can say, we'll take all the target characters from this column, and then we'll call the recursive call on the next character starting at the next index. Seems a little bit complicated, but hopefully it'll make sense when we get into it. Okay, so let's see. Let's find how many characters we have. So let's do a character count, or target character count. How about that? So that's just going to be our grid. We're looking at this character, and we are looking at the column I. So let's see, grid at column I for this target character index. Okay, so we're looking for this target character in this column of our grid. All right, now let's see. Now we do our recurse, I guess. So we can say our result will be increased by this target character count. So however many characters we have here times however many characters we can get back, or how many ways we can form the rest of our target word. So that's going to be our recurse call here. So how many ways can we form the rest of our word starting at the next index? So that's going to be start index. Oh no, it's not start index because we are at index I. So it's going to be from I index plus 1. So we can't choose anything at this index or before. We have to go to the next index. But we can choose the next target index. Okay, so this should give us our result. And then at the end, we do need to do our result. Okay, let's go out here. So we have to do our initial call. So this result out here will be equal to our initial recursive call. And we start at 0 and we go to 0. Are we looking for target index 0? And then the result itself, we have to return mod, it says over here, mod 10 to the 9th plus 7. All right, so that's going to be pow 10 to the 9th plus 7. All right, almost there. I think there's one thing we're missing here. Let's just take a look through this. So we're going to build our grid. That's what all this is. That part is totally fine. We looked at that. Then we're going to say, starting from our 0 column, we're looking for the 0 indexed character in our target. If we are out of bounds, these are our base cases, we'll just return 0. If we're still in bounds, we'll find the target index or the target character's index. Then we'll look for that in our grid. Say, hey, how many of this character do we have at this column? Then we can take that and we can multiply by the number of ways we can make the rest of our target starting from the next index. I think one issue here is when we step out of bounds, we'll be returning 0, which means that this will be multiplied by 0. I think in our final case, when we're at the last index, we don't want to be stepping across that bounds because we'll be returning 0. So we actually need to check here. All right. Is this right? Yeah, we only want to recurse if we still have more targets to go, more characters in our target to go. All right, so we have to check if the target index is less than the length of our target. In fact, it's length of target minus 1 because we're stepping 1. Oh man, this is complicated. Otherwise, let's see. I think then our result is just going to be the number of characters in this column. So we're at the last character that we're looking for in our target. So that's just going to be this target character count. So that's going to be a result. It's going to be incremented by this target character count. Oh man, this is complicated. Let's see how this works. I'm sure I have typos. All right. This is target length. Okay, so holy smokes, that works. One thing, I'm not even going to submit this just yet, because one thing we can do, we already know that we're using cache to make this faster, but it looks like this can be used, we can use cache here as well, because this just takes 2 simple inputs. So we can use caching to make this faster. So let's do this. And we will submit that, see how we do. It's taking a long time. I don't know if we're going to be able to pass this one today. Time limit exceeded. Oh, but we got 84 out of 89, so we're pretty close. All right, what can we do to speed this up? Are there any things that I'm doing here that we could do better? I'm not seeing a whole lot. We're only taking the length once up here. We're not doing any mins or maxes. One thing. So this range, we're just saying from the start index up to the length of the word. Let's just check every character. But what happens if we are at, say, the last index in our target? Or not the last index, we're in the... But what happens if we're at the last index of our dictionary word, but we still have 3 characters left in our target? There's no way we can complete that. So that's one issue. There's another issue that's like, well, what happens if we have, well, maybe that's the only one. Yeah, if we don't have enough words or characters left in our dictionary word to complete our target, then we can exit early. So that's one thing we could do. The other thing we could do is, yeah, we only want to go up to a point where we have enough characters left. So we only recurse if we know that we have enough characters left. So this can be changed as well. Oh man, let's see. Maybe we'll start with the first one. So what is that first one? We need to check to see if there are enough characters left in our word to get to our target. Okay, so let's do this. Target characters remaining. That's going to be equal to, let's see, that's going to be the length of our target, or the target length, minus 1, because that's the max index, and that's going to be minus our target index. Let's see, actually, we won't do the minus 1, because if we're at the target index, if we're at the last index, this will be 0, but there could be still one character that we're looking for. So let's do this. All right, if we don't have any characters that we're looking for, actually we can return 1, I think. The other problem is if we have enough characters left. So let's say here, let's have some end index. Right now we'll just set it to word length, and we'll replace this with end index. We'll eventually fix this up because I don't think that's what we want. It's not going to give us enough speed increase, I think. Yeah. Okay, so what's this new end index? Well, let's see. Will be either the start index. I definitely know I don't want it to be too small. I don't want to go below the start index. And how many characters can we have? Well, we can't go past the index where we would not have enough characters left for our target. So let's see, we have our remaining target character. We have our word length minus the remaining target characters. But I think we need to, oh no, that might be it. So let's say our word is 5 characters long. We only have 1 character. This is getting too confusing. Oh, but this is, nuts. Let's ignore this. This is not inclusive, so we need to add 1 because this is a range. Shoot. All right, let's try this one last time, and then I think I have to call it. We're really close. We have 84 out of the 80-something test cases passing, so we are really close on this one. Oh, and we do pass. All right, we do not great. We only beat 5% for runtime and 45% for memory. So this is not the best algorithm by far. You've got a huge area of improvement here. There's 94% you can improve on. So that's all I have. We're out of time. So check this one out. Again, this is LeetCode problem 1639. It's a hard one. Check it out. It's fun. And yeah, see if you can do better. All right, hope you enjoyed this. Hope you had fun. Hope you learned something. Hope you can go out and write better code.